Yeah, students, today we are going to have the second video of refrigeration, that is basic refrigeration cycles. The refrigeration is a cyclic process. Here we have four parts. One is compressor, second one is condenser, third one is fourth one is evaporator. Here between every component there is one flow is there. First one is the reverse Carnot cycle. Here, as I mentioned, there are the four components: compressor, condenser, throttling or turbine we call as, or evaporator. Here, evaporator is the main component which is visible to us. If coming to the refrigerator, the refrigerator box is called as a evaporator, or if it is coming to the air condition, air condition vent is our evaporator. Compressor is internal to the refrigeration unit. Here entire it may be the fluid is compressed there and it is heated, the temperature is added there, and we are going to push into the condenser where heat is exhausting from the system to surroundings. Turbine, here it is changing the fluid into liquid. If you go to the chart of TS chart beside that, 1 to 2 is a evaporation process, 2 to 3 is a compression process, 3 to 4 is a heat exhaust or a condensation, 4 to 1 is a turbine. So here we have two cycles. One is two cycles. One type of cycle is isothermal and isentropic. Isothermal is the process which is having without changing of temperature. Coming to the process 1 to 2 and 3 to 4, there is a parallel lines with respect to Ts, means it is a constant temperature. Coming to 2, 3 and 4, 1, those are isentropic, means there is no entropy generation. It's a constant entropy between 2 to 3 and 3 to 4 to 1. Here 2 to 3 is a compression, 4 to 1 is a turbine or expansion or throttling. We can find the coefficient of performance of a, it is a reverse Carnot cycle. Coefficient of reverse Carnot cycle performance, that is 1 by Th by T1 minus 1, or we can say as every time the coefficient of performance should be greater than 1, then only we can say it is a good refrigeration cycle. Next we are going to have somewhat near vapor compression refrigeration cycle. It is isothermal, isentropic and isenthalpic. Here same one, here we process change just. 1 to 2 is a compression, 2 to 3 is a condensation, 3 to 4 is a expansion, 4 to 1 is evaporation. These are the cycles we are generally happen. So we can say here, you are checking here like saturated vapor, superheated vapor, saturated liquid plus vapor. So these are the things of we having the matter thing we are learned in the thermodynamics. So I would like to say one here. Let us take saturated vapor. Saturated vapor is nothing but the entire vapor is converted from liquid to vapor. There is no any liquid particles in the saturated vapor. Superheated vapor is nothing but the vapor which is heated beyond some temperature. It is called as superheated. Saturated liquid is nothing but, coming to here, saturated liquid. Saturated liquid is nothing but which is converted after removing the heat of the liquid. The liquid is, the vapor is converted to liquid. Means after compression, condensation heat is removed, it went to the air. So expansion, after expansion is nothing but after changing the pressure, automatically expansion is nothing but changing the pressure and increasing the volume. Here it is converted into saturated liquid plus vapor. It is a semi-liquid or semi-vapor we can call as. We can go for chart. Here we have TS chart and pH chart. We have two charts. So here first we will check of TS chart. Ideally, we are going for ideally only, not for real purposes. So here the main work we are doing in the refrigeration is the compression. Everything part is the stationary part, and compression and condensation we are going to have the mobile parts. So in 1 to 2 we are going to give a work done. We are increasing the pressure. We are increasing the pressure. Let us take yeah, coming to these two charts. 1 to 2 we are increasing the, we are giving the work, nothing but we are increasing the pressure from 1 to 2. We say isoentropic. Entropy is constant here, but pressure is increasing. Due to pressure is increasing, the temperature is also increasing. We already seen that in the before one. It's a saturated liquid to saturated vapor to superheated vapor. So as we are increasing the pressure in the same fluid structure, means in the vapor only, the temperature and pressure is going to increase. Coming to the process 2 to 3, heat is exhausting from the our system. Means in condenser the heat is exhausting into surroundings. You can check the thick line. This is called as saturation line, which is after the above or after the saturation line is vapor, internal is a liquid, on that is, on the point is semi liquid. Coming to 1 to 2 is in the in the vapor state. So it is where is increasing the temperature and the pressure. It is increasing the superheated state. It is going here from 2 to 3, and it is coming to, because of temperature is decreasing. You can see here 2 to 3 the temperature is decreasing on constant, temperature is decreasing on the constant pressure lines. 2 to 3 is a constant pressure line. In the same pressure we are not changing anything. The same pressure, the temperature is increasing after some certain point, is called a point. It is converting into saturated liquid. You can check here, saturated liquid, it is converting into liquid. After expanding from 3 to 4, it is coming to, from vapor to, from liquid to, it is liquid only. It is in liquid only. It is liquid only. 3 to 4 we have two times. One is 3 to 4s is isoentropic expansion. Ideally, really it is no isoentropic expansion not happen. If it is this happen isoentropic, then we called as reverse Carnot cycle or equal to Carnot cycle, but it's not. It's a vapor compression cycle. Bell-Coleman cycle we generally call this as Bell-Coleman, or Brayton cycle we called as this. Reverse Brayton cycle. These all things. Okay, this is the basic refrigeration cycle which we have to learn. Yes, end of this chart. This is very important to your examination. You can refer this video how many times you want.